right, thanks so much for the kind introduction. And yeah, let's get started and let's talk about LLM applications for a bit. All right, cool. So basically, the goal of this talk for me is for you to take away a couple of things, right? So first, in the first 15 to 20 minutes of the talk, I want to talk about the basics of large language models, not like the internals or how they work, but basically how to think about them from a practitioner's point of view and how to build with them, right? So that might include which models to choose. There's a lot of them. How to access them, right? Because there's also many options, and what challenges we faced in production and what we learned, right? We did a lot of experiments in the last couple of months and gained some insights. And along the way, I also want to teach you about Ray and how to scale workloads with it, right? And the second part of the presentation is about applications we built in practice. And I'm just going to show you or demo these applications and then point you to a more in-depth treatment later on. Like if you're interested in building something like that, you can just copycat what we did and build your own stuff, right? So that includes a QA bot and some GitHub bot that comments on your pull requests, okay? And we see more about that later. Okay, cool. So on a very simplistic, high level, large language models are these very expensive black boxes into which you put some prompts, some text as input, and hopefully out comes some useful text, right? Something that helps you with your use case. And one thing that is absolutely clear is not only are they hard to understand in terms of interpretability, like how they actually work, although we make some progress on that front as well, but they're also very hard to evaluate depending on what use case you have in mind, right? It's not always clear in the end to say, is that really like a good answer, or can I expect something more from the system? Okay. And something that we see in the last couple of months, predominantly with the closed source models, like the commercial models, we're going multimodal, right? So we're moving from LLMs to LMMs, large multimodal models, which take more modalities as input and potentially as output. Not necessarily at the same time, but in some combination or form, right? So there are models specialized on code that you can ask for code and it outputs code, or you have models that you prompt with, let's say, images and text, and it outputs text as well, or like images, right? And hopefully, in the next couple of months, we'll see more development on the open source models as well, catching up with that kind of picture here. All right. Something that's also quite interesting and important is how language models interact with different systems and parts of the ecosystem, right? So you can describe this as tool use. If you regularly use, for instance, ChatGPT, you know that's capable of browsing with Bing in this particular instance, or that it can execute code or do some advanced data analytics, or interact with some APIs in the background, some plugin system of sorts. And another thing that's very important and that also kind of dampens some of the bad effects that you see with wrong outcomes and hallucinations in language models is data augmentation, specifically retrieval augmented generation, which we talk about a bit more in a couple of slides, to kind of help enrich the context of your input prompts to improve the output of your, the fidelity of your models, okay? All right, and then the question is, should you train these models yourself? And of course, if you know a bit more about that, if we talk about the first stage of training, pre-training your own foundation model, that is certainly not possible unless you work for a really big company, OpenAI, Google, and co. But if you want to fine-tune an existing model to your specific use case, may it be a very simple supervised fine-tuning or some form of reinforcement learning through human feedback, that is certainly doable, and it kind of depends on what use case you have, if that makes sense and if it's feasible, right? And for the experts among you, if you know what that is, we have a very in-depth treatment about when to use full parameter training versus LoRa. And I encourage you to check out this blog post. It's very detailed and tells you when to do kind of which type of fine-tuning. All right. So zooming out even more, like if you incorporate all of that, multimodality, tool use, all of that, like what we really want from language models in the future is them being not just simple chatbots and chat interfaces, but truly agents that act autonomously and do tasks on their own by sitting at the center, basically as the CPU, if you will, interacting with users, interacting with code, interacting with APIs, and so on, right? And there's a really nice blog post, not written by us, but I like that very much. It's called The Rise of the AI Engineer that I want to point you to. This is a really nice kind of role description of a new role that's emerging, that's going beyond just being a prompt engineer or terms like that you hear sometimes, but really someone who's working on all parts or some parts of the equation for building agents, right? Yeah, and I think the upshot in some ways, also moving into the demo section soon, is you should think about LLMs as kind of building blocks that you as engineers or scientists, data scientists, engineers, can use as part of like the bigger picture, right? And introduce them to your toolbox and do cool stuff with them, right? There are no experts yet. Okay, cool. Of course, there's the kind of the 800-pound gorilla in the room. Like OpenAI dominates or has been dominating the discussion, especially as of late, and they're making a lot of money commercially, but also a lot of ground scientifically when it comes to building cutting-edge closed-source language models, right? And what you see on the left, since we're at PyData, this is kind of the standard way you would interact with OpenAI if you wanted to get some answer from their chat system, right? So they have a chat completion API in which you specify the model, in this case GPT 3.5 Turbo, which is kind of their second best model available for pure language models. And you specify what it has to do, and you give it some prompt, and it outputs something, right? So this is the basic way of interacting with OpenAI as a Python developer. One of many, of course. All right. Quickly changing gears here. So kind of a little known fact. The company I work for, Anyscale, builds the software called Ray, which is used for distributing Python workloads specifically for machine learning and other workloads that need more flexibility than other systems allow. And ChatGPT and all the other large models at scale at OpenAI and Eleuther and Cohere, for that matter as well, have been trained on Ray as the infrastructure layer down below, right? And it's a good idea to consider and look at Ray, because I don't think I have to convince you as a PyData crowd that Python is everywhere, but also machine learning is growing as a field. And we see that scaling more and more is becoming a necessity, right? So you cannot really get around scaling to multiple machines. Even if you have like really beefy machines, if you're using them in the cloud, it's usually at some point, if you're doing something non-trivial with larger models, you have to scale out at some point. Not just for training, also for inference, right? All right, and this is by no means like a product pitch, but I just want to mention that Anyscale, as the company behind Ray, is you can think of it as like a hosted Ray solution, right? And it's trusted by many industry partners that you see listed here. All right, so in a bit more depth, not really introducing too much here, what is Ray? All right. I already mentioned that it's kind of a flexible distributed Python system, right? So you can scale out your workloads from your laptop to a cluster of computers, but you could also, for instance, use it on just your laptop to use it as a drop-in replacement for multiprocessing or something like that, right? If you have something that's embarrassingly parallel to parallelize on your laptop, you can do that efficiently with Ray, even just on your laptop, because Python has some limitations with multithreading and so on, right? So on the low level, Ray is a distributed compute engine, right? So it has a distributed scheduler. It can kind of schedule and execute tasks. And one layer on top of that, you have a very elegant, and I'm going to show you this in one quick example on the next slide, a very elegant core API. And Ray Core basically has primitives that allow you to scale Python functions to Ray tasks and Python classes to Ray actors, right? So there's a one-to-one correspondence between kind of stateless structures and functions and stateful structures in actors, right? So if you want to do anything that you want to scale out, you basically just put like a decorator on top of your Python function or your class, and you're more or less ready to scale out, given that your cluster is set up properly. All right, and on top of that basic Ray Core layer, we have a suite of really interesting libraries for model training, supports PyTorch, supports TensorFlow, all the good stuff. We do hyperparameter optimization with RayTune. It supports Optuna, HyperOpt, and many other libraries. Serving models with Fast API, for instance, and all of that is kind of batteries included to scale out on your cluster, right? Okay, cool. Right. So here's a quick example. I think I indicated that already on the last slide. But if you have any function called f in Python that takes two parameters, a and b, and it just returns the sum, right? Might make sense for strings or numbers. Then basically you can decorate that function with a ray.remote decorator and give it some optional kind of scaling configuration that tells it how to scale out the individual tasks. And if you then call, instead of just f of 1 and 2, which would return 3 locally, if you put f.remote 1, 2, it would be executed on a cluster, right? And if you do that with, let's say, a list comprehension, right, these individual tasks would be able to scale that out on several machines. And if you have a workload that requires scaling out, which this one obviously isn't, but if you do, this would all be taken care of for you. All right. Yeah, and you see a lot of these integrations that I mentioned in the bottom. Cool. Quickly about me. Thanks again for the introduction. But I'm doing engineering at Anyscale. I'm working in the rapid iteration team, which is responsible for kind of building and scaling and productionizing LLM applications at Anyscale and making the services that we build internally available for everyone. Also teaching data science, and I'm a book author, right? And I think maybe some of you have already seen that I brought a couple of copies, like 25 copies or so. They're at the booth next door. If you already got your copy and you didn't come to say hi, please find me. I can sign your copy if you want to. There's still a couple of books left. Just go find me after the talk. I can give you a free copy, right? If that appeals to you. Also, something you should know is that the book is basically free online, right? So if you would just want to have the PDF version and you're willing to give your sacred email address, you can get it for free as well, right? Cool. And then the last point, which is kind of important and which kind of brings me here to PyData, I've been contributing to the Python ecosystem a lot since basically 2014. I think I've been only doing open source work, so kind of GitHub is the place I live, more or less. And yeah, so I started with Keras and TensorFlow, have been maintaining HyperOpt for a while, and am now like a core contributor to Ray. So if you have any questions or want to talk to me about any of these logos you see, or want to help maintain any of these projects, please approach me afterwards. All right, cool. Right. So there's not just ChatGPT, right? There's other models as well from other companies producing closed source models, but we also have a growing ecosystem, a whole zoo really, of open source models that are trying to catch up with the closed source versions. And the one model family that is really considered strongest right now is the Llama 2 family from Meta. Which kind of tops out all the leaderboards of the non-commercial models, right? But there's other models that are similar in strength, like Falcon and others, right? And now the question becomes, if I don't want to use OpenAI for whatever reason, or I want to try something else, how can I access other models? And of course, there are a few canonical candidates like Hugging Face. Fireworks AI has a really nice integration for open source models as well. And there are many others, right? So I don't want to act as if this list is complete. Cool. All right, now what? Remember this? Like this is the OpenAI Python client. This is how you interact with OpenAI, right? And if you look closely, skipping to the next slide, if I just replace the API key from an OpenAI API key to an Anyscale API key, and I change the model from GPT 3.5 Turbo to Llama 2 70B or 13B or 7B or the Code Llama model, I can basically do the exact same thing. So we're basically hijacking the OpenAI API. You don't even need to install in the library, right? So you just need to sign up, for instance, with Anyscale. Some other competitors do something similar, right? It's very common to kind of clone the OpenAI API or integrate with them and support a different suite of models, right? And so what I'm saying is that if you look into the market and you take a look around, you see that there are other models available that you can use kind of in the same way, right? And Anyscale is not special in that sense, but I just want to point out that this is a viable solution here that is also quite cheap and fast, right? All right, cool. So now the question really becomes like, when do you need which model, right? And it kind of depends on your use case. I think I mentioned this before in the beginning. So for instance, we figured out, and you can read the blog post about that on the Anyscale blog. We found out that Llama 2 is absolutely sufficient for text summarization. So you don't need GPT-4, right? It's also better than 3.5 Turbo for some reason. They are kind of the most comparable. So Llama 7DB and GPT 3.5 Turbo are quite similar in many respects. But Llama 2, keep it in mind, is kind of 30 times cheaper than GPT-4 and much faster, right? So if you have a very restricted and limited use case, going for an open source model might actually make sense, right? Another use case that is not by us, but that I found kind of appealing is if you want to do some interesting use case like recipe classification, where you have some online resource of recipes and it's free text, right? So that can be handled by a language model, and you want to classify which type of recipe it is, right? You can do that with a language model. You can just say, here's the recipe in text form, give me a classification. What is it, right? Is it a dessert or what? If you do that on the nose with GPT-4, you're down like 23K, right? So that's quite a lot of money. But if you fine-tune a Llama model, which you can do in a couple of minutes, basically, costs the whole thing of this whole classification task costs $20. Right, so this becomes affordable all of a sudden. And of course, I don't know which kinds of use cases you have, and I'm definitely not claiming that like open source models can always help you. But you'd be surprised if you get your hands dirty and try some of the smaller open source models, how they can actually compete in some use cases. All right. So, and of course, there's a couple of factors that you have to keep in mind when you look at which models to pick, right? Obviously, this list goes on forever, but quality, speed, cost are basically the big ones. All right, cool. So, when to fine-tune models? This might not be super interesting to those of you who have never done any fine-tuning task on language models, but this is kind of a current trend. People do it more and more, right? And we did like this really cute experiment where we fine-tuned a Llama model on basically a corpus of text that incorporated the works of Shakespeare, right? And we tried to make Romeo Bob, yeah? As you all know, Bob and Juliet, yeah? And so we fine-tuned, we kept fine-tuning again and again, and we tried to change the fact that like the main character's name is not Romeo but Bob. It doesn't work, right? The language model refuses to change kind of its ground base, right? So if something is not grounded in the model and you want to change that, you want to change the facts, it's not possible. But if you want to change the presentation and what the model should be focusing on, what it should be outputting, what format it should be outputting, what aspect it should be focusing on, that is very much possible, right? And we did some other fine-tuning case studies in which we showed that you can easily generate SQL queries to sufficient quality with fine-tuned Llama models and tackle grade school math, which I think is cool. All right, yeah. And now let's move over to some demos. Like I said, the main purpose is not to give you like a drill down into what exactly happened. If you want to clone like what I do, you can read it after the talk, just to give you an impression of what is possible with models like that. All right. So the first application I want to talk about is Documentor. Documentor is basically an open source GitHub bot. On the first link, if you want to check that out, you find basically a link to GitHub, and you can just single-click deploy that bot on your own open source project. And then whenever you open a pull request, it will basically critique what you wrote in the pull request, right? So this is kind of cool. And I also put up an example PR, but we will see a video of Documentor in practice, right? Cool. And one thing I want to point out is that the fast responses we get from Documentor are due to Ray. Because instead of just asking a language model once, we basically scale out several requests for all the files we have in parallel and get responses from each of these models at the same time. So basically, by distributing the whole thing, we reduce wall clock time for larger pull requests, right? So this is kind of cool. So now, hopefully, that starts.
Let me introduce you to Documentor, a new GitHub bot deployed to improve the writing in your pull requests. This bot is powered by Anyscale services and Anyscale Endpoints in particular. And if you want to check out its source code, click the link below to GitHub. All right. Let's say we have a new pull request that changes two text files, one README, just Markdown, and one Python file that has a docstring, but both files are kind of flawed, have grammar mistakes and spelling errors. All right, let's create this pull request. And once we do, you will see that within a second or so, Documentor will actually respond by greeting you and telling you how to use it. The main command is Documentor run. And if we paste this command into a new comment, the bot will be triggered and we will get a response soon. While this command is running, let me tell you about how Documentor actually works. So technically speaking, it is a GitHub app that needs to be installed on your GitHub repo. And once you mention the bot, it will get triggered and send a webhook request to our backend service, which is an Anyscale service instance, which will in turn query Anyscale endpoints, in this case, a Llama 7dB large language model. And this will respond with improvements for your documentation. And the Anyscale service will then leverage the GitHub API to write back a comment on your pull request. All right, let's see how we did. And you will see that Documentor finished analyzing the PR and it commented on the README and on the test file. It has some detailed instructions, and usually it finds all the grammar and spelling mistakes, and it also gives you improvements on how to do that. Like, for instance, here the parameters for your doc string could be added. All right. So how does it work in the background? Instead of sending all the request data for the diff in your pull request to one large language model, which can be quite a lot of work, we split up the work with a array task and send the content for each file, in our case, just 2 files, but it could be much more in practice, to an individual large language model call. All right, this is done with Ray, right? And how do we know that it's actually any good? This is difficult, but the way we approach it is we first ask GPT-4 to generate some flawed sentences, like minor short sentences or some paragraphs, and then we ask Documentor to improve it, after which GPT-4 has to judge the results of that. And if both of these systems, Documentor and GPT-4, agree largely, we consider this a good result. And so far in our evaluation, we've seen that Documentor actually gives quite solid and decent results. And of course, systems like these can always be improved, but we're quite happy with what the bot can do right now.
All right, cool. Yeah, apologies. I had to pre-record things because I did not, the guys did not want me to give the demo today. But yeah, anyway, that's Documentor. I hope you like that. If you want to do something similar, like it doesn't have to be about that. Comments on your pull request could be anything else, right? You can basically just clone this blueprint from us and do something else. Right, and the second application I want to show you real quickly is an Ask Me Anything bot for the Ray documentation. And I think you've seen that, or like most of you might have seen that. This is popping up everywhere, left and right. So if you go on any technical documentation these days, usually in the right-hand corner, you see like a button, Ask AI, and then you can interact with the website, right, and ask questions about the content. And the cool thing is that we basically built something like that end-to-end by ourselves, and we documented the process so that you can do the same, right? Cool. Right, there's another much quicker video, which I have to walk you through. So this is the Ray documentation, and if you click the button in the right, and you ask a question, like give me a Ray core code example, it will then proceed to stream the response and dynamically render the Python code for you. And as you will see in a second, like inline code is also handled. And we also provide sources to the files in which you find the answer or stuff that you might be interested in, right? And so, yeah, basically that's already kind of the whole demo. But just want to point out again that like this whole system has been trained by us. So we basically scraped our own documentation, chunked it accordingly. I should go to the next slide. We chunked the docs accordingly, split it up, put it into a vector database. For that, you need to create some embeddings. Can't really talk about that in detail here. And once you have these embeddings, you can basically query your database for similarity. So if somebody asks a question about your documentation, you pick up from your database the most similar content, whatever that might mean, and enrich the context of your language model with the stuff you have from the database, including the sources, the links, and then you crunch through your model and get a good response, right? And we also built a front end for it, so it's really fully end-to-end, right? And one thing I want to mention at the very end is that we also have something that's kind of nice, which is a so-called model router, which you see in the right, because we kind of trained a classifier to capture whether an open source, weaker model, but faster and not as expensive, would be capable of handling the question, right? So if it's not too technical of a question or too deep of a question in terms of knowledge base, you can defer the request to an open source model, and otherwise you can use GPT-4, right? So and this kind of smart router system is something that we dive into more and more because I think it's very useful. And instead of having like a fully trained supervised classifier, you can also have like just a text file that you provide to yet another language model, and this language model basically decides which one should answer, right? And so there's a lot of really cool things that you can do if you want to save some time or some money. All right, that's pretty much it. Thanks so much, and yeah, any questions?
Thank you. Yeah, very interesting presentation. The Q&A model that you just showed, I assume that it did work with fine-tuning, probably, or not?
No.
Okay. So it was a completely different approach, because, so maybe you can explain that further, because I'm also looking for a Q&A. Do I have to fine-tune, or do I have to do some prompt engineering? What is the...
Yeah, so
what is the way to go there?
I think you can do both, but like the standard approach for tackling such problems is basically to go ahead and do like a retrieval augmented generation playbook, right? This is basically what I'm outlining here. Mm-hmm. So basically, you take your data sources and you chunk it up in some way, right? Could be sentences, for instance, if it makes sense. Like if it's purely text-based, splitting by sentences might make sense. But if you have code, like several lines of code might belong to each other, so to speak. So it kind of depends on your strategy, right? Mm-hmm. And you can basically ask your system also to optimize that part, right? So we did some hyperparameter optimization on the chunking strategy, right? And this is a bit going a bit far, but you can definitely do that. And once you have that, you embed these sentences, right? And then you have this vector database with embeddings of your core content that you want to enrich your prompts with, right? So, but this is not prompt engineering in a manual way, but it's like an automated retrieval of relevant context. And the way that this is done is, that's why we use vector databases. By the way, like if you check out this blog post, it's like a 50-minute read or something like that. So it really walks you through every single step, and you can reproduce it at home, basically, right? Okay. But the reason you use vector databases is because they have this really nice property of having efficient lookup, right? Because you have just vector representation of actual text, and you want to retrieve the text, right? But then you have to do some sort of similarity matching of that. Yeah. But let's say I find the top 10 most relevant things. You're not like in production. You're not even done yet. Like there's interesting topics like re-ranking that you should take into account. But let's say you just have these top 10 rankings. You get like the initial sentences back and enrich the original question. So it's the original question plus your top 10 list, and that goes into your language model. Yeah. And then you get the answer, right? Okay. And this drastically reduces hallucination, right? So this RAG technique is omnipresent, right? And I think, I think it's even in the assistant API by ChatGPT. So they do that implicitly without really telling you much about it. Okay. Yeah.
Thanks.
Just one quick question.
Thank you. Great talk. We try to implement Llama at a company with only Dutch data. Mm-hmm. How can you adapt? Is like fine-tuning fine for switching language?
Well, to be honest, I don't know how strong the Llama models are in specific languages, right? This is something you always have to figure out, but kind of more fringe languages, let's say, or languages that are not as strongly represented in the data sets originally used, tend to work worse. But I think I can only encourage you to do your own experiments with this. But fine-tuning might definitely work in this case, right? Because under the assumption that enough Dutch is in the training data set, you might massage the model into giving you more specific kind of Dutch answers. Yeah, and something else you might want to check out is there are a lot of kind of initiatives to have kind of these no language left behind kind of approaches where you have specific models for each language. And I think the open source alternatives for that are getting stronger as well. So if you don't at the same time also need some sort of domain specific application or so, like you want to have Dutch, but also, I don't know, code, like Python or so, then you might be better off with having an even smaller model that only is an expert in Dutch, so to speak. Yeah.
Okay. Thank you.
Sure.
Thank you. Thanks, Max. Sorry, I would love to ask more questions, but now's the next time for the next talk. So please find Max outside and also get a copy of his book.
Thank you.